Okay, so Assalamualaikum warahmatullahi wabarakatuh and a very good day. Today we are going to go through the example 9.52. This example is in your textbook. You can open your textbook and go through together with me. So this question is about the oxidization of methane and air. Okay, so for the production of formaldehyde and also occur a side reaction to the formation of carbon dioxide. So it is a multiple reaction processes. So given in the question also the inlet of methane of 100 and also the process flow diagram. Okay, so you can refer textbook. So the question requires the rate of heat that must be transferred. Okay, Q. Okay, to or from the reactor. Okay, at 1 atm. Okay, so as you can see on the flow chart, you already solved the material balance calculation. So you can skip the process flow and also the material balance calculation. Another one is about the method, which method you want to use. Okay, so for the multiple reaction, it is easier to use the heat of formation method compared to the heat of reaction method. Okay, so in this example, you are going through the exercise, the calculation using this particular method. So because we already formed our method, then we go through on the reference state. So for the heat of formation method, our reference is in the element form. So how you want to write it down? So you check on your process flow diagram. Okay, so we have element of carbon, okay, hydrogen, oxygen, and nitrogen. Here is also in the repetition form. Okay, so our reference is in carbon. So carbon naturally or in the standard condition is in a solid form. Okay, and then hydrogen normally in gas, oxygen gas, and also nitrogen in gas. Okay, and temperature 25 degree. Okay, standard and 1 atm. Okay, so once we solve the reference state, then we move forward on the inlet and outlet enthalpy table. So I just copy all the substances available in the process flow. Okay, so CH4, oxygen, nitrogen, and then formaldehyde, CH2, then CO2, and then water. Okay, and then also the mole inlet and outlet is given. So just translate it into the table. Okay. So for the formaldehyde, no inlet. Carbon dioxide also no inlet. Water also no inlet. So this one is B. So this one 60. Formaldehyde is 30. Okay, and then oxygen is 10. Okay, and then sorry, oxygen is 50. Okay, and then carbon dioxide is 10. Okay, and then nitrogen 376. And then lastly is the water. Water is 50 mole. Okay, that one. Okay, so for the heat of formation method, we need to calculate the enthalpy even though the temperature in is equals to the reference state. Okay, so I will show on the calculation later. So we just note this as a H1, H2, then H4, H5. Six. Okay, So once we fill in all the information in the table, we are now moving on the calculation, okay, of the unknown specific heat. Okay, so start off with the H1 till H9. Okay. So for the H1, our reference substance is methane. Okay, it is in the gas form. Okay, so temperature 25 degree C. Okay, so for the before I started, for the heat of formation, the way to calculate on each enthalpy is this. For example, for substance I, so formation for that particular substance, enthalpy of formation for that particular substance plus with the enthalpy of that substance at temperature at that particular temperature. Okay, so if T in is 35, then 25. Okay, okay. So this is the general equation for the enthalpy, specific enthalpy calculation. Okay, so now we move back to the methane. So it's equivalent to H1. Okay, so H1 is equals to heat of formation of methane. Okay, at standard plus with the heat of methane, specific hot of methane at temperature 25 degrees C. Okay, so the heat of formation for all substances is in table B1. You can refer it there. So now for this one, normally we go to integration Cp dt, or we can refer to table B8. Okay, depends on the substances. Okay, so for methane, the case of the temperature is 25 degree, which is equivalent to the reference state. Okay, so then this one, the value is negative 74.85 kilojoules per mole from table B1. Okay, so this one, because it's similar with reference state, is equal to 0. So negative 74.85 kilojoule per mole. Okay. So now we move to the next substances, which is oxygen. Okay, so oxygen gas, the temperature in given for oxygen just now is 100. Okay, you notice. Okay, so H2, so similar. Oh, for delta. Okay, so forgot the delta. HF standard for oxygen plus oxygen at temperature 100. Okay, so for this one, you need to refer table B1. Okay, so for oxygen, we don't have to go to the CPDT. The data is in our table B8. Okay, so heat of formation for oxygen is equals to 0. Okay, so because it's a gas, standard element gases naturally occur. Okay, and then from table B8, you can straight away take the data equals to 2.44, 2.24, sorry, kilojoule per mole. Okay. So now we move to the next substances, oxygen, nitrogen. So nitrogen in the gas, 100 degree C. Okay. So H3. Okay. H3. So using similar equation with just now. Okay, this one. Okay, so formation of nitrogen is also 0. Okay, so you can also take the specific enthalpy of nitrogen at 100 degree at table B8. Okay, so the value is 2.9 kilojoule per mole. Okay, so okay, this one. Well, we already complete on the inlet part, so you move to the outlet part. So CH4, gas 100, sorry, 150 degrees. The outlet temperature for the products is a 150 degrees C. So noted as H. Oh, just now in your textbook, in our table, sorry, in the steam table, so equals to change of HF standard for the formation of methane plus with the um, H specific heat of methane at 150 degrees C. Okay, so this one is from table B1. You can take directly. Okay, table B1. So methane is not available as a substance in table B8. So you need to refer to table B2. Okay, so negative 74.85. Okay, plus with the integration from 25 to 150 Cp dt. Okay, so you include all the information and integrate the data for the methane through this equation. Then you get the final answer for methane 69.95 kilojoule per mole. Okay. And for methane, then we move to the oxygen. Oxygen in gas 150 degree. Okay, so H5. Okay, so formation, change of formation for oxygen plus the specific enthalpy for oxygen at 150 degrees C. Okay, so you can refer table B1, and then this one oxygen is in the table B8. So if it's in the table B8, so the data is in temperature 100 to 100. So you need to do some interpolation to get the value of enthalpy at 150 degrees C. Okay, so formation of oxygen is 0. Plus with the E 3.775. Okay, so you get 3.775 kilojoule per mole. Okay, so it's quite long, the calculation. It's simple but repetition of calculation, okay, of all components. So we have also nitrogen gas 150 degree using similar method as above. So you get the answer 3.66 kilojoule per mole. Okay, and then we move to the HCHO. Okay, in a gas 150. Okay, so determine, the H6. This one is H6. Okay, so H7. Okay, so change of formation of the HCHO. Okay, standard plus the HHCHO specific enthalpy at 150 degrees C. Okay, so you get the answer 1.115 kilojoule per mole. Okay, so for the which says formaldehyde. Okay, so formaldehyde is not in the table B8 as a substance, so you need to find the data in table B2 and do the integration from 25 to 150. Okay, Cp dt. Okay. So similar calculation for the carbon dioxide. Carbon dioxide gas also 150 degrees C. So H8. Okay. So you need to find the formation. Okay. For the carbon dioxide plus with the H for the carbon dioxide at 150 degrees C. And then last one is a water H2O. It's in a vapor. So 150 degrees C. H9. Okay, so you determine the HF for H2O plus with the H for H2O at 150. Okay. Okay. So for both substances, this one is in table B1. Okay. And then for this one also similar interpolation from table B8. Okay. So you got all the values and then you need to determine the enthalpy change. So I already put in a table form. Okay. So for the general equation or for heat of formation method, so it's quite simple. Delta H equals to summation of the N H out minus the summation of N H in. Okay. Okay. So that's why I extend a bit of the table here. Okay. So I just directly put all the information here. Okay, so I got here is 100 times 74.85. Okay, and then 224. Okay, and then 823.44. Okay, so I got the value here negative 6,437.56. Okay, so and then for the outlet, okay, this is the value. Okay, so uh, N outlet times with the H outlet for each substances, and then you sum it up, then you get the answer for the total negative 21,729.69. Okay, so the summation of NH outlet minus the summation of NH inlet. Okay, so you get the answer negative 15,292 kilojoule. So I forgot the unit here is kilojoule. Okay. As well as this one, kilojoule. Okay. Okay, so we already solved the value for the enthalpy change. Now we move to the energy valence equation. So the question is in our open system. Okay. So we go to the general equation, delta H plus delta EK plus delta EP equals to Q minus W. Okay, so the question doesn't mention anything about movement, potential, and also work. So Q equals to delta H and also equivalent to negative 15.3 megajoule. Okay, so that's the final answer for this particular question. Thank you very much and have a nice day.